Welcome to the second module in a series of 14 modules on the fundamentals of telecommunications. Today I'll be discussing with you the principles of electrical circuits and telecommunications signals. Once again, I'm Ted Chandler, your instructor for this online course. After completing this module, you will be able to first describe the principles of electricity that underlie all telecommunications signaling. Then you'll be able to explain the concepts of current and voltage as they apply to telecommunications technology. And you'll be able to describe the components of an integrated circuit, explain the difference between analog and digital transmission, how to use binary encoding to represent decimal numbers, and finally, you will be able to describe various electricity and data transmission measurements. So let's take a look at the atomic model, which is the first step in understanding electricity and electronics. A charge is a fundamental property of a material that exerts a force on another material. Neutrons, found at the center of an atom, possess no charge and are said to be electrically neutral. Protons, also found at the center of the atom, carry a positive charge. Electrons orbit the center of an atom and carry a negative charge. In stable matter, these charges are balanced. When matter has an excess of either protons or neutrons, it is said to be electrically charged. The three main characteristics of a circuit are voltage, current, and resistance. Voltage is the pressure that the electrical current exerts on its conductor. It is commonly equated to the strength of the electrical current and measured in volts. Amperes is the amount of current or charge flowing through a wire each second and is measured in amperes, abbreviated amps. Resistance is a material's opposition to electric current flow and measured in ohms resistance. If two of these characteristics are known, the third can be calculated using Ohm's law, which states that the amount of current flowing in an electrical circuit is directly proportional to voltage and inversely proportional to resistance. Other things to know about electricity include that an electrical current is the controlled movement of an electrical charge or electrons along the atoms of a conductor. In order for current to flow in a circuit, the circuit must be completed. It is a close connection between an electrical source, such as a battery, and a load, such as a lamp, over which current may flow. And finally, a signal occurs when current is manipulated to transmit information. To help you understand how an electrical circuit works, take a look at this analogy compared the electrical characteristics of a circuit with a physics experiment in hydraulics that you may have performed in high school. Take a few moments to study this slide. First, note that the two unequal columns of water are connected, similar to a battery's plus and minus post, yet separated by a water valve or an electrical switch. Then note that before the valve is opened or electrical switch is closed, completing the circuit, a difference of 12 inches water head or voltage potential or electromotive force in electrical terms exists. Recall that the water level will seek equalization, or 24 inches, which results in a potential head pressure of 12 inches. That is 36 inches minus 24 inches. This is like a 9-volt battery that is completely discharged. And also note that when the valve is opened or electrical switch is closed, completing the circuit, the water is allowed to flow, representing current in an electrical circuit. And finally, note that the pipe connecting the columns together has a certain resistance to the flow of water depending upon its size. And this is similar to resistance to current flow in an electrical circuit. There are two distinct types of electrical current: DC or direct current and AC or alternating current. In direct current, an electrical charge flows steadily in one direction over a conductor. In alternating current, electrical charge flows alternately positive then negative. AC current can follow a sine, triangle, square, or some other waveform. As I said in the previous slide, in alternating current, or AC, the electrical charge flows in one direction first, then in the opposite direction, then back in the first direction, and so on, in an alternating fashion over the conductor. The strength of the voltage is indicated by the wave's amplitude, and the number of times each second the wave cycles from its starting point through a full oscillation back to its starting point is known as frequency. Frequency is measured in hertz, or the cycles per second. Also note that wavelength is the inverse of frequency. In a circuit, voltage is measured by a voltmeter, current is measured by an ammeter, and resistance is measured by an ohm meter. A device that can measure all three of these variables is called a multimeter. An oscilloscope measures the change in voltage over time or oscillation on an AC circuit. A frequency analyzer converts the time domain into a frequency domain for its type of display. Electrical power in a circuit is a multiple of its current and voltage. In other words, voltage times current equals power. Note the differences of power requirements for various electrical devices. A conductor is a material over which electrical current readily flows. Grounding is the use of a conductor, such as a wire, to divert unused or potentially harmful charges to an insulator, which they will be stopped or absorbed. Insulators are materials that do not allow electrical current to flow. Semiconductors conduct electricity better than an insulator, but not as well as a conductor. Analog refers to signals that use variable voltages to increase continuous waves, to create continuous waves, resulting in an inexact replica of the original message. Digital signals are composed of pulses of zero voltage and precise positive voltage that represent values of either 0 or 1 respectively. The use of ones and zeros to encode information is known as a binary system. Every pulse in the digital signal is called a binary digit or a bit. A bit can only have a value of 1 or 0, which equate to on and off respectively. 8 bits together form a byte. Digital transmission is more reliable than analog transmission. Because of their reliability, digital signals can be transmitted at higher speeds for longer distances and with higher quality than analog signals. Analog signals can be converted to digital signals using a modem, which means modulation, demodulation, and digital signals can be converted to analog signals using a codec, which means encoder, decoder. The use of ones and zeros to encode information is known as a binary system. Every pulse in the digital signal is called a binary digit or bit. A bit can only have a value of 1 or 0, which equates to on and off respectively. 8 bits together form a byte. Most text messages are encoded in a simple scheme known as ASCII-2. ASCII-2 represents English letters, numbers, special characters, and punctuation marks. Capacitance is the ability of an electrical circuit or component to accumulate or store a charge. Capacitance is measured in farads, a unit named after English chemist and physicist Michael Faraday, who experimented with electricity in the early 1800s. A capacitor is a device that stores electrical charges, such as a water tank that can store water. A resistor is a component that, when used in a circuit, provides a specific amount of resistance to the flow of current. Resistors are passive components that contribute no power gain to a circuit. Inductors use the magnetic field that is generated when a current is passed through an inductor, typically a wire coil. Inductance is measured in henries. Transformers use inductance to boost or lower voltage levels. A diode is an electronic component that acts like a one-way valve. As a discrete component or built into a chip, it is used in a variety of functions. Used as a rectifier, it is a key element in changing AC to DC by limiting current flow to a single direction. Diodes are used as temperature and light sensors and light-emitting diodes. In communications, they filter out analog and digital signals from carriers and modulate signals onto carriers. In digital logic, they're used as one-way valves and as valves similar to transistors. In the analog world of continuously variable signals, a transistor is a device used to amplify voltage or current, or sometimes function as an on-off switch. In the binary digital world of computing, a transistor is mostly a switch and is a fundamental building block of computer circuitry. Like a light switch on the wall that lets electricity flow to a light bulb, the transistor acts as a simple electronic switch, either preventing or allowing current to flow through. The active part of the transistor is made of silicon or some other semiconductor material that can change its electrical state when pulsed. In its normal state, the material may not be conductive and either impede or let current flow. When voltage is applied to it, it changes state to the opposite means. Made out of a semiconductor material, integrated circuits, or ICs, combine the conductors and their attached components of numerous circuits in one small unit or chip. ICs are used in almost every electrical and electronic device manufactured today. Integrated circuits are often classified by the number of transistors and other components they contain. For example, small-scale integration, or SSI, chips use up to 100 electronic components. MSI, a medium-scale integration, from 100 to 3,000 electronic components. LSI, from 3,000 to 100,000 electronic components. Very large-scale integration, from 100,000 to 1 million. And ultra-large-scale, more than 1 million electronic devices per chip. Please take a few moments and review these two charts, noting the engineering units used in measuring electricity. Now let's take a few minutes and just review a little bit the transmission flaws in telecommunication devices. I'll be going into this much more in Module 8 when we talk about network cabling systems and so forth. But for now, let me just review these. These are the most important aspects regarding transmission flaws. Noise is unwarranted interference from external sources which can degrade or distort a signal. Attenuation is the loss of signal strength as it travels away from its source. Crosstalk is the introduction of spurious signals and interference from internal cables or wire pairs. An amplifier is an electronic device that increases the voltage or power of the signals. Regeneration occurs when digital signals are repeated that are actually retransmitted in their original pure form without any noise. Repeaters are devices that regenerate a digital signal. Bandwidth is the range of frequencies between the highest and lowest that a transmission medium can carry in a given period of time. Transfer throughput, transmission, or bit rate is the speed with which transmission media carries data expressed in bits per second and depends on the media's bandwidth in its transmission. And again, all this will be repeated again in Module 8, and we'll go into data transfer rates and transmission flaws in much greater detail in Module 8. Take a few minutes and note the data transfer rates of various systems and physical media. You have learned in this module on the principles of electrical circuits and telecommunication signals the following. When electrical current is manipulated, it can generate and transmit information as signals. The three main characteristics of a circuit are voltage, current, and resistance. If two of the characteristics are known, the third can be calculated using Ohm's law, which states that the amount of current flowing through an electrical circuit is directly proportional to the voltage and inversely proportional to the resistance. There are two distinct types of electrical current, direct current and alternating current. In direct current, an electrical charge flows steadily in one direction over the conductor. In alternating current, the electrical charge flows in one direction first, then in the opposite direction, then back in the first direction, and so on, in an alternating fashion over the conductor. AC voltage follows a sine wave in which the strength of the voltage is indicated by the wave's amplitude and the number of times each second the wave cycles from its starting point through a full oscillation back to its starting point, and it's known as frequency. Frequency is measured in hertz. Devices useful for controlling current include capacitors, inductors, and transformers. A wire may be coiled around a conductor core, such as an iron, to produce an electrical magnet, which is a specific type of inductor. Electromagnetics are used in motors and some telecommunication devices. Electrical power in a circuit is a multiple of its current and voltage. In other words, voltage times current equals power. In a circuit, voltage is measured by a voltmeter, current is measured by an ammeter, and resistance is measured by an ohmmeter. A device that can measure all three of these variables is called a multimeter. An oscilloscope measures the change in voltage over time on an AC circuit. Electronics is a field that deals with the behavior of electrical charge as it flows in a vacuum in gases and in semiconductors. In general, the term electronics apply to power controls and communication devices such as computers, whereas electricity applies to motors, lights, and appliances. Electronic devices may be either passive or active. Examples of passive devices are capacitors and inductors. Examples of active devices are transformers and diodes. Integrated circuits contain many tiny components in one enclosed unit. They are inexpensive, reliable, small, and they require little power and generate relatively little heat. Analog refers to signals that use variable voltage to create continuous waves, resulting in an inexact replica of the original message. Digital signals are composed of pulses of zero voltage and precise positive voltage that represent values of either 0 or 1 respectively. The use of ones and zeros to encode information is known as a binary system. Every pulse in a digital signal is called a binary digit or bit. A bit can only have a value of 1 or 0, which equate to the on and off respectively. 8 bits together form a byte. Digital transmission is a more reliable transmission method than analog. Because of their reliability, digital signals can be transmitted at higher rates for longer distances and with higher quality than analog signals. Noise is unwanted interference from external sources that may degrade a signal. It affects both analog and digital signals, but affects analog signals much more profoundly. Attenuation is a loss of a signal strength as it travels further away from its source. To compensate for attenuation, both analog and digital signals are boosted en route to travel farther. However, analog signals may pass through an amplifier, whereas digital signals are regenerated in the original pure form. In the binary numbering system, each bit has a decimal equivalent of 2 to the power of its position if the bit is on, in other words, equal 1. This completes Module 2. Please review Quiz 2 and move on to Module 3.